Yeah, hello, welcome everybody. Actually, I just added the title itself this morning because I forgot about it. And also there's another slogan we use usually, which is Open Earth Data for Humans. So Wetterdienst these days also covers not only weather data, but also some hydrological data. And maybe the slogan resonates with some of you from another library. No? We actually took it from requests, which uses HTTP for humans. So the idea is just to make it as simple as possible to retrieve weather and also Earth data in a few lines of code. Wetterdienst also stands for Weather Service. And also a little warning, I will use the word DVD, which stands for German Weather Service, and I think the English pronunciation of DVD is just it's not good, so I will skip that. Here's a little introduction. So I'm gonna introduce myself again a little bit. I'm talking about the journey of Wetterdienst or to Wetterdienst, then about Wetterdienst and its features itself, then the value that it gives to you, me, and to everyone, hopefully. Then we have a little demo, and afterwards the questions. So, I'm 32 years old. I'm a happy resident of Hamburg. I have several hobbies, so I usually play football, but I also like to go to Hamburg's biggest football stadium. I play also volleyball, and also by day I like to walk Otto on the right side. And by night I like to go to cinema and concerts, for example in the famous Mojo Club on the Reeperbahn. But obviously I also do coding by night when there's some time left. I studied hydrology at TU Dresden, so I'm from the environmental sector, so from 2013 until 2020. When people ask me what is hydrology, I first tell them water. And the second thing I'm telling them is it's basically the entire water cycle, so from the clouds in the sky up to the bottom, to the groundwater. And why Dresden? Dresden has a long history with severe floodings. You see in the middle a picture of Dresden in 2002. The entire city center was flooded. And on the right you see from the same year a picture of the main station. Imagine what conditions you had during this period. So I think that's a big relation between the city and hydrology, and in this case of flooding. Yeah. Since 2022, I'm at Otto Group DataWorks, which is also part of 1.0. We are also here with, I just put up the picture on the right. We are here with a big group of people. There are many young people also there. When I joined them, it felt a bit like just being at university again. So not a real change. And at the Otto Group, I'm working usually on rankings for shops, but also these days we are working on generative AI-based bots, which I'm feeling really lucky about because we can use all the nice technology, and we also are on the Google Cloud, so we have access to all the features of the Google Cloud, and yeah, it's a real pleasure to work there, and you get to learn lots of stuff. So then about the journey to Wetterdienst, I'm starting at how you can work as a hydrologist. So there are many different possibilities. For example, on the top left, some people like to go in the field, do some measurements on rivers like velocity and chemicals, and other people also go into simulation. For example, on the bottom left, the groundwater simulation is an important part. Others may go to some companies that manage reservoirs and do some predictions and forecasting for the capacity. And on the bottom right, some people tend to stick to university or to some research. And actually, this is the Institute of Meteorology, and this is also where I started with my bachelor thesis, which was about homogeneity. So homogeneity in terms of precipitation time series. So I was tasked to research the homogeneity of Eastern Saxonian precipitation time series. And homogeneity in this case means, so usually you have your precipitation station, and you do the measurements all the time, but and then maybe over decades, over hundreds of years, climate may change. And this could cause a disruption in the time series. So it may jump, or it may, there may be a trend upwards. But there could also be external cases or like external changes in the surroundings. Like, for example, a house is being built, the station could be moved 100 meters further, and then suddenly you have other conditions there, and precipitation may be also different because of those different conditions. And you want to make sure that when you say precipitation changes in this area, it's not because of the surroundings changes, but because of actual climate changes. So, and this had to be done for, like I said, Eastern Saxony with roughly, I think, 95 stations it was. And you could imagine this is not being done by Excel, but instead, and this is, I think, a typical entry to scripting and coding in the university. It's not Python, but I think it's R, rather, because it's really simple. You have your script, you can run line by line. I think it's easier to understand for the beginners. So this is how I started, so I was not into Python back then. But my interest was sparked, and I continued working in the university. And then I thought, I have the opportunity as a student to join some conference for cheap money. So I went to Brussels in 2017, which was really nice. And there was also a talk about RDWD, or RDWD, by a colleague who I think worked in Potsdam Climate Research Institute back then. And it felt really nice, like you have really only a few lines of code to retrieve some data, which I think basically back when I worked in the institute, they did still some transfer of, like from, I don't know if they sent them hard drives from the DVD to the institute. And this library would just make it so much easier to retrieve the data. And in the same time, I thought R is not enough for me. I think you can do some stuff with it, but Python has so much more capabilities. So I want to learn Python. And I have already a library that I like. And I need a project which I can use to learn Python. So I'm just going to port it over to Python. And that's how it actually went. Along the way, I want to mention two important things. One is my mentor, I call him. I don't think maybe he doesn't understand it like that. But it's Andreas Muckel. He's like a legend in OSS development. Check him out on GitHub. He has many projects. Is in software development for already decades, I guess. And he was or is active in Beehive community, and they have relations to weather data because they like to measure temperature, because bees tend to leave the hive when it gets cooler, and they come back when it's warmer. So there was his interest for weather data and also for the library. Yeah, and he joined me, helped me set up a clean structure for Wetterdienst in the beginning, and also some state-of-the-art CI/CD pipelines. And he also comes back every now and then also, honestly, it pushes me also just to put again some more time into Wetterdienst, which is not always the case in the last month. And and then also, which is really important, is open data, because Wetterdienst could not afford providing data when, like, for example, I would have to pay for the data. I would be bankrupt. But luckily, there's open data these days. And I think it's great because it enables research privately as well as institutionally. So, and this is great because in times of climate insecurity, it's good to have a single source of truth. So we can just look into the data and prove the climate change we see outside, maybe, or in the models, which is also important, but also in terms of global insecurity. So it's good to have multiple institutions because, you know, these days some institutions may quit or not provide data anymore and run models. So it's really important to have, I think, multiple institutions like DWD and also, like I said, many national weather services publish their data already, like Deutscher Wetterdienst. since 2017, and they do it really accurately. So basically, I think everything they measure, there's a data set for. It's a real lot of data they provide. But there's also other services, for example, in Europe, the Geosphere. It's basically the environmental agency of Austria. They also have an API these days. And NOAA, the US version of the environmental agency, also publishes the data in 2018. And they have the benefit, like in terms of the data wealth fee, that they also ingest some of the data of the German weather service, but not all of it, because they have they are tied to fixed resolutions. They have data in daily resolution and also in hourly, but nothing more than that. And also, I forgot, open source software is obviously also really important, because Wetterdienst relies on Polars, Fast API, Click, and many more, and those are obviously also really important for Wetterdienst to work. Yeah, now let's look at Wetterdienst itself. So the statement is, retrieve the entire climatological history of a place or a location, like, for example, say Darmstadt. And this in less than 10 lines of code. And this is actually what's the case these days. So you just need to import combination of provider and network. So provider would be DVD in this case. And the network I call it observation. So it's observational historical data. It's not forecast data, but it's historical. And then you just define the parameters you want. For example, in this case, it's in daily resolution, the climate summary data set, and from that, the parameter temperature mean 2 meters. So this is a regular measurement in 2 meters height in this, I think it's called English hut or something, they measure it in. Plus maybe some start and end date, plus maybe some settings for the unit you want to have the temperature values in. Yeah, and then as you see also you need some kind of station. First the results. And like I said, the results, the core results are Polars data frames. I think everyone can work with it. Even like in the university, everybody knows data frames, everybody loves them. On the top you see first the station list. So basically you see on top we filter for station Dresden-Klotsche, and then you get one row with all the information for that station. So it's basically, again, the parameter is listed there, like daily and climate summary, then the ID, then start and end date, and some geographical information which is important to filter it out in a way. And then the actual values. So there you get the list of values. You also have a quality column on the back, but we won't talk about that today. Yeah, and here you also see the details about the request. So it's daily, climate summary, and then the parameters. So the response is full of the details we have or we need from the request. Then there's also a metadata model, which is important to define all kinds of no-code stuff that basically describes the data set in its hierarchy. So there's some information about the provider and the network, some kind of metadata. Then there's a resolution, which shows how the values, in the resolution of the values that you retrieve basically, so daily or hourly or whatever. The data set, so it's the data set's name and some other definitions, and then maybe most importantly the parameter model, where you also have this definition of unit. Sorry. And the benefit of it is also that you can rewrite your request using this model with a dot annotation. Yeah, and it's based on Pydantic, I forgot to mention. So, and the other thing you need is the simplest form. You would just have to define or to do some implementations for two abstract methods, which one is all method for the station list, and the other one is a collect station parameter dataset. And this second method does all the collection for the data itself, so it fetches some data from the API. There's different methods for the selection of the station. So typically in the beginning, you don't know which station you actually are looking for. So who knows the ID for the Darmstadt station? I don't know. So in the beginning, you could just request all the stations. And then from this list on, look up the ID of the Darmstadt station. And once you have that, you could just go with filter by station ID. Or alternatively, you could do a fuzzy search for Darmstadt as a city name. Or you do some bounding box search if you're interested in stations in a certain bounding box. You could also do a ranked search for X number of stations closest to latitude-longitude pair. Or just retrieve all the stations in a certain distance. But there's also SQL filtering for the stations you want to retrieve data for. And if no station is found, there's also interpolation and summary methods these days. And they try to automatically fetch as many stations as reasonable. So you don't typically want to fetch all like 100 stations that would be able to use for interpolation, because it takes ages. So instead we do like we try to fetch as many stations as feasible to interpolate as much data as possible in a certain date range. And this is important to notice. This works best for homogeneous data like temperature. Temperature is really equal over the area, but precipitation is really inhomogeneous over the area. So it's really different if you're looking at precipitation in Darmstadt or in Frankfurt, for example. There's also many different exports. So from the data frame, you can go on to some databases. You have file exports, and you have also many different formats also in Python objects. So you can just continue with your whatever setup of database you have locally. There's also a CLI, I think. Everybody has a CLI today, and also Wetterdienst. So this thing also replicates a request you've seen before. You could just rewrite then the request with the CLI, but also there's if you install Fast API optionally, you can do the same with an HTTP request. And the same, I show you the same for one for stations, and the other thing for the values. And there's also an app these days. Shame on me, I vibe coded it because I'm not a front-end developer. And the idea here is just to simplify the access for people who cannot code or set up a VN for whatever. Like I think my mother, for example. And the idea is, you have different applications. One is the Explorer, where you can just also replicate the request I've just shown you, just in a UI way. There's also climate stripes. You may have seen them already on some events. It's a nice way to express climate change for your city. Maybe I can also show it later to you if you want. Station history is showing the metadata of some stations, but this metadata is for many services not available. I think at this time only for DVD. And there's also the REST API itself. So basically, the HTTP request I've just shown you can just also send it to this app, which is running on Wetterdienst eops.org. One more thing. This is a Wetterdienst. This is a DVD API. So it's a plain file server. There's no actual API, and this is also the best reason why Wetterdienst actually started, because you would just have to go through all the files manually and look it up yourself. You see even here the station list is not a real CSV. You have to do some manual parsing there, or like fuzzy parsing. But I think we are still lucky because they provide just so much data, DVD. For example, this extensive dataset description where you find all the information about the parameter. And there are also some quirks, but I think we don't have too much time for this, so I will just skip that. Yeah, and then what value did it give us? So I think for me it's fun, and also obviously the result belongs to me and you and everyone, and it's not hidden behind a business case. It's a good place to try out new stuff, and then usually if it works like new tooling, I also tend to take it to my workplace and implement it there. But there's also many impact on many businesses and processes, for example, agriculture, construction industry, for example, where they rely on temperature forecasts for concrete drying. Insurances, for example, where they want to show that a hazardous event was caused by this historical rainfall, for example. Autonomous driving, I've also seen, so people use high-resolution precipitation data for training on the rain sensors. And then obviously also the research on climate change itself. But my hope, I think, yeah, people who are into this already know how to get the data, or they are in reach with me. But my hope is also for you to inform yourself. So, but I'm still figuring out how to improve Wetterdienst or the Wetterdienst app for this case. Yeah, now the demo and vibe code alert again. What I did is, because I think I wouldn't want to rely on the internet here, so I just dumped the daily climate summary dataset into a DuckDB file, and I created a Marimo notebook around it. The DuckDB file I put also online, so if you want, you can just do your own SQL on it. So I'll jump over to PyCharm. Just started. And I did some analysis of some analysis of this data. So first thing we see is, yeah, here's by the way the code snippet, how I created the DuckDB file. So I just used some to-target function here to pump the data into a DuckDB file. Yeah, and the first interesting thing we see is the station network of this climate summary data set. We see there are a total of 1,200 stations, but currently there's only 566. So there's been obviously lots of changes going on in the past. We see also the historical development. The first station was opened in 1759. Yeah, and then we see by 1900 it was still quite scattered. 1950 it looks already better. Yeah, and today we have a really dense network of stations here. What I asked, what question I asked myself is the impact of war, and you could see here that in the First World War there was no real impact, but I think it was also not so many stations maybe. But then in World War II you could definitely see a decline in stations during the end. So I think you always also see this kind of historic events, and sadly in this case, also in the data. So there's also some gaps in the data usually you see during the World War II period for Germany. Yeah, and there's another interesting effect. I think we talked also during my work at the institute at the university, and you see here in the end, usually you would expect, well, we have developed a good network. Now maybe let's continue, or even or just maintain the same number of stations. But there's actually a decline here, and I think there were two reasons. One is that usually the network is that there's volunteers working on it, usually retired teachers, I heard, and they have to go to the station every day and check if everything is okay. And actually, I think this is hard to acquire those people, those volunteers these days. And it comes also with a side effect. So DVD, at least when I was in the institute, we were discussing this. So DVD, I think, tended to replace people by like automated technique, like cameras and this kind of stuff. And they were actually not really happy with it, because it would, or they would implicate that the quality of the measurements would go down with this, with this change.
All right. Well, I guess we are short on time. We have 5 minutes for the Q&A session, if that's okay. I will read out the questions one by one. Okay, the first question. Is interpolation between multiple stations purely mathematical, or does use some kind of meteorological model in the background?
Yeah, good question, because also you have some sometimes difference in the height of the station and this kind of stuff. So yeah, geometry also I think should play a role. But honestly, at the moment I can say no, except we do some additional technique for precipitation interpolation, which is because there are days where there's zero precipitation, but usually when you interpolate, you always get not zero, but really close to it. So for the case of interpolation of precipitation, we do another interpolation of has it rained or has it not rained, so 0, 0, 1, and then we do the cutoff there to say the interpolated value is either 0 or above 0.
Yeah, makes sense. The next question is, as polars is relatively new, did you start with pandas? Did you have any conversion problems, or do you miss any features in polars still?
Yes, we started with pandas, but like I said, we like to play with the new stuff, and we were happy to see this advertisement by polars. It's really fast. It has lots of optimization. Honestly, I don't know what it means in reality, but we switched directly to polars when we thought it would have the most necessary features. And I think in the beginning we had also some workarounds. I think these days it's quite complete for what we need. So we do just some cleanup mostly on the data, and then for that case it is already in state.
Yeah. Next question. The logic is set up so that if a good weather station isn't found, it pulls data from several nearby ones. But does it take elevation into account? With just a straight line distance, whether you actually get similar data seems like it would depend on the station.
Can you repeat?
Yes. The logic is set up so that if a good weather station isn't found, it pulls data from several nearby ones. But does it take elevation into account?
No, for the elevation, no. At the moment, no.
All right. What amounts of data do we talk about when working with weather data?
So I've shown you like on the daily, so those daily values obviously are the ones that reach most back in time, because it is just 1 time per day measurement. One person could go to the station, check the value, and like return home. And those values reach into 18th century, so it's a really long time series. I think you find maybe only older ones in England. And for the higher resolutions, they don't reach back that long. So for example, we have this 1 minute precipitation data, and this starts, I think, in the 1990s. And I think also, that's the answer. 1 minute and 10 minutes don't reach back that long, maybe in the 90s.
I guess we have time for one more question. Which kind of distance are you using when searching for stations?
Like
the units, maybe they mean.
Yeah, right. I don't find the name right now in my brain, but obviously we cannot just we have to do some like projection distance calculation. I don't know if that answers your question correctly, but I don't have the name in my brain right now.
Thank you. You can ask him after the session. Well, thank you so much. Okay, let's thank our speaker once again.